Let's now take a look at packet crafting. This enables network administrators or hackers to probe rules set for the firewall and identify vulnerabilities. Now, packets are manually generated to test network devices and their behavior. You may test firewall, IDS, TCP/IP stack, router, or any component of a network. Now, packet generator or packet analyzer enables us to create packets with options to set flags. Packet crafting generally has 4 stages. Let me begin by saying the first one is packet assembly. Second, packet editing. Third, packet play. And finally, packet decoding. Tools are available to support each of these stages.
Banner grabbing, or OS fingerprinting, is used to find details of the operating system running on a target system. Now, you can identify an operating system either in passive mode or in active mode. In active mode, specially prepared packets are sent to a remote computer and responses is analyzed to fingerprint the operating system using OS databases. In passive mode, error messages are used to decipher information about the operating system. So you may have to sniff network traffic in order to find this information. Now, when you use nmap command with the -o local host options, it will list port numbers with the protocol used. Now, it could be TCP or UDP protocol. It's also going to show whether the port is open or closed and the service details, such as SSH, HTTP, etc. This can also give version details of nmap. Fragmentation is complex and the implementations may have bugs and inconsistencies. The IP message header, after splitting into small fragments, is transmitted over the network. Now, at times you may observe unpredictable results, such as fragmentation of the data in the IP header after that reassembly of IP on the server side. So some hosts may not be capable of parsing and reassembling the fragmented packets, and thus may cause crashes, reboots, or even network device monitoring dumps. Possible tests could examine how overlapping fragments are assembled or time the defragmentation timeouts. Many firewalls and other inline devices defragment traffic at gateways, leaving nmap to fingerprint the firewall, not the true destination host. POF, or Passive OS Filtering, is a very useful tool to administrators, and it is a passive traffic fingerprinting tool. It can identify the programs and tools behind TCP communication. It does not interfere with the traffic in any way. It can collate information about machines that your computer connects to and machines that come onto your network. It can detect, even if a machine is behind a firewall, so it's a really powerful tool. It can determine details of the location of the machine's uptime, and to which network or ISP it is hooked. It can detect certain types of packet filters and NAT setups. Remember that it is a passive tool and it does not cause any traffic traces, etc.